this is what's happening. Let's say that, for example, we start off with a nice normal distribution where the mean is, I don't know, 8 and sigma is, I don't know, how about 5? Just making numbers up there. So let's say I have that distribution there. What I want to be interested in is taking samples. Okay, so here is some random variable x. And what I want to do is, let's say I take a sample of size, again, I'm just making stuff up here. How about size 3? Samples of size 3. So the variable n, size n equals to 3. N represents the sample size. So for example, one random sample could be drawn from there, and maybe it's the numbers 5 and 2 and 1. That could happen, sure, why not? And so we could find the mean of our individual sample that I randomly chose. The mean would be indicated by x bar, which would be 8 over 3 in this case. So 8 divided by 3 is 2.67. And so that's that first one, right? Okay, we're going to do it again. We randomly select some more values. Now, this distribution up here tells me that the most likely outcomes occur around 8. So maybe the values are like maybe 9 and maybe 7.2, right? So it doesn't have to be nice, pretty whole numbers. It could be any decimal value as well. I'm just being lazy and not putting very big decimal numbers. But keep that in mind. It can be a decimal, 0.042, for example. Here are my 3 randomly selected values from that. Okay, so now I want to find the mean of that sample. So that'll be x bar equals to 9 plus 7.2 plus 8.042. Divide that by 3. Let's see, what do we get? 9 plus 7.2 plus 8.042 divided by 3. I get 8.08. Okay, well, you get the point. We do this over and over and over. We keep going, we keep going. We get lots and lots and lots of samples. Every single sample contains 3 randomly selected values from this distribution. And for each individual value sample, I'm going to find a sample mean. Okay? So, chapter 8.1 tells us that if we do this, right, we do this for an infinite number of values there, we get all these results, and we graph all those results, it's going to turn out that those results are normally distributed. Normal distribution of sample means. Right? So every one of the dots in here, every one of these values represents a mean from a sample of size 3 that came from that population over there. Okay? So that's a very important distinction. The parent distribution from where the samples came from, we have the variable x, and then we take samples of size 3, lots of samples. Every sample has a particular sample mean, and now if we graph all those values, like say this value was 2.67, that's some number here, 2.67. And 8.08, that's going to be some number over here at 8.08. Some dot there, some dot there. And then we do it over and over and over and over and over and over. And we find that those results form this nice normal distribution. Okay? The mean of this distribution, we're going to denote it as mu sub x bar. Mu sub x bar is going to be equal to the mean of the parent distribution from where the samples came from. So in this case, this example, it would be equal to 8. That's always true. Okay, so I'll write that down over here. This is where mu sub x bar is equal to mu. Okay, so we put this little subscript of x bar to identify that we're talking about the mean of the distribution of sample means with little x bar, and not to be confused with mu, which is the mean of the parent distribution from where the samples came from. Okay. And then the other thing we need is the standard deviation. So the standard deviation of x bar is going to be equal to the standard deviation of the parent distribution up there divided by the square root of the sample size, which in this case was 3. Okay, so let me put that over here. So standard deviation of x bar is equal to the standard deviation of the original distribution divided by the square root of n. Okay, so for us, we had 5 divided by the square root of 3. What is that? I'm getting 2.8868. 2.8868. Any questions about that? Okay. All right, that's a very important concept in statistics, and this is always true as long as we adhere to the conditions. What are the conditions? Well, the condition is this. If the original parent distribution is normal, this is always going to happen. Guaranteed. Okay? No matter what the sample size is, you are guaranteed that the distribution of sample means is going to be normal, and that the mean and standard deviations are going to follow this little property as long as the parent distribution for where the samples came from is also normal. Okay, that's one thing. Now, what if this is not normal, or if we don't know if it's normal? It could be uniform, it could be anything else. What if it's something other than normal? Well, it depends. The sample size needs to be big enough in order for this to work. So the bigger n is, the more likely it is that this distribution of sample means is going to be normal. So that's kind of an important area of study for statistics. If this was a more advanced stats class, we'd spend some time kind of looking into more detail of that. But here, we just want to, simplify it a little bit. So for us, in this class, if this sample size is 30 or bigger, then we don't care what the distribution looks like. We're guaranteed this will work. Okay, so for all our questions, one of those two things will happen. Either the sample size is bigger than 30, in which case we're okay. It doesn't matter what that distribution is. We're guaranteed that this will happen. That the distribution of sample means will be normal, and that the mean and standard deviations will follow this property. As long as the sample size is bigger than 30, we don't care what the parent distribution looks like. On the other hand, the other kinds of questions we'll run into will automatically let us know that this distribution is normal, therefore we're guaranteed this. So the only questions we cannot do in this class is when this sample size is less than 30 and we are not guaranteed that this is normal. If we run into a situation like that, we can't do it in this class. We don't know what that means. Got it? Okay, so that's the only source of problem. Sample size is less than 30, and at the same time, the parent distribution from where the samples come from has an unknown distribution. We're not guaranteed that it's normal, so we have issues. Do we have any questions so far? No?